I want to talk now about the graphs of inverse functions. We've discussed the fact that when we take an inverse function, we're switching the roles of x and y. Okay. And so I'd like to sort of see if we can figure out what that amounts to graphically. Now, if I had a point 1, 2, and that was on the graph of f, I know that the point 2, 1 would be on the graph of f inverse. I would just literally switch the roles of x and y. Now, if I have individual points, it's very easy to do that. But if I have a curve that's infinitely many points, that's going to be fairly tricky. Now, it turns out that what this is this is really just the reflection of this point about the line y equals x. So it's like there's a mirror on this line y equals x. This point looks in that mirror, and on the other side of that mirror, it sees its mirror image. So the graph of the inverse function will always be the reflection of the graph of the original function over this line y equals x. However, while that's very cool, and often people can see that, it's a little bit tricky because we're not used to thinking of there being a mirror on this diagonal and then seeing mirror images. I mean, usually like a mirror is just on the wall. It's not at some weird angle and some weird slant. Okay. So, although everything I've just said is true, there's a nice shortcut that I think makes it a lot easier to graph inverse functions. And it involves just figuring out what it means to literally switch the roles of x and y. So what I want you to do is take a piece of paper and on it draw me an x and y axis and label. That's the x-axis and that's the y-axis. Now, I've got that up here on the board, but I also have a prop. I have a piece of paper here, and that's important. You need to be able to move the paper around. This is not waving a white flag of surrender. This is actually manipulating x and y in ways that it's difficult to do when they're attached to the wall. Okay. So, just to make things super, super clear, I'm going to even emphasize this is the positive x-axis. This is the negative x-axis. Up here, this is the positive y-axis. Down here, this is the negative y-axis. Now on my piece of paper here, I've got the x on the side of the positive x-axis and the y where the positive y-axis is. Now what I want to try to do is see what is it like to just switch the roles of x and y. So the first thing I'm going to do is I'm going to take this paper and I'm just going to rotate it 90 degrees to the right. When I do that, what I was calling the y-axis is now horizontal, and what I was calling the x-axis is now vertical. Okay, so we're going to rotate 90 degrees to the right. And when we do that, now we've got the positive y-axis sort of lay down. It's taken a nap, so the negative y-axis is over here. Now, the positive x-axis rotated down to here. So I've got positive x here and negative x here. So I have successfully switched the horizontal and the vertical, but I haven't preserved my orientation. Horizontally, I preserved the idea that to the right is positive. But vertically, I've changed the orientation, so then now we're saying positive is down. Well, I don't really want to do that. I prefer to have it so that positive is up. So, while I've got this piece of paper here, where the positive x's are down here, what I'm going to do is I'm going to take this paper and I'm going to flip it top to bottom. Now, if I do that, notice what happened. Right now, this is the side that has writing on it. I flip it top to bottom and I'm looking at the back side. Okay? So, I'm going to flip it top to bottom. Now when I do that, I'm now looking at the back side of the piece of paper, but I wrote in a thick marker. If I hold this up to the light, I can still read, and I can see, oh, that's what I had labeled as X. That's where I had my positive X's. And there's where I had labeled Y. That's positive Y. So now I've got negative Y over here still, negative X here. All I did was flip the positive and negative on the vertical axis without changing the horizontal axis. So this successfully switched the roles of X and Y, preserving the notion that right and up were the positive directions. This is very cool. This is how I'm going to graph inverse functions. So what I'm going to do is I'm going to graph x cubed. So y equals x cubed looks like this. And I could call that, let's call it f of x. Okay. Now, the inverse function is going to be f inverse of x will be the cube root of x. Here I got that by just saying, how would I undo what this function is doing? I undo cubing by taking the cube root. And odd powers and roots do undo each other perfectly. Even ones are the ones that don't. Okay, so I'd like to now graph the cube root of x. Now that was one of our parent functions, so I should already know what the graph looks like. But as a general rule, we use the cubing function more than we use the cube root function. And so sometimes people forget the cube root function. So what I'm going to do is I'm going to take my piece of paper and I'm going to sketch my cubing function on it. Now I'm going to turn and flip. Okay. So I rotate 90 degrees to the right, and then I flip it top to bottom. And then I look, I hold it up to the light, and what I see is something that looks kind of like so, which should be what I get. I know that's about what the cube root function looks like. I do need to be careful here. Okay. Now notice originally my paper was oriented the tall way. When I turn and flip, now it's oriented this way. Okay. This right here was the original y-axis, but that was for the original function. What were the y values become the x values for this function. And what were the x values become the y values for this function. So I don't label this horizontal axis as y, because I'm saying these are the y values from that function, but they're the x values for this function. Okay. Now, it is totally acceptable on exams and quizzes to do this. To say, here's my function, my answer's on the back. You turn, you flip, you hold it up to the light, and then you really quickly trace what you saw and said, okay, that's my function. But when you do that, you've got to somehow label it so that I know that this is the top of the page. So just label that this is the x-axis and this is the y-axis. Otherwise, I might be looking at this and you say my answer's on the back, and I turn it over this way and I say, no, that's not the inverse function. That's not the cube root function. So do make sure that if you use this turn and flip, you tell me how to orient the piece of paper where your answer is. Okay? You will, of course, be uploading your work, so you'll be taking pictures of things. So what you can do is just orient the paper the correct way and then take the picture. But it's a good idea to just make sure that your axes are labeled. All right, I want you to have some practice with sketching inverse functions. There are only a few of these in the textbook, and there were only 2 odd numbers. Now, I assigned both of them. What I'm going to do is I'm going to have you work through in the videos the even numbered problems so that you have a little bit more to practice on afterwards. So that's going to be problem 72 and 74. Okay. So if you want to grab your book and do those before watching the next video, that's great. At the start of the next video, I will have the graphs from those 2 problems up on the board, but generally it's easier to read the graphs, I think, out of the book rather than trying to copy them off of the whiteboard in the video. So, up to you.